Huh? Can you check one? Can you check once? I'll get the AC in the meantime. Working, right? Okay, fine. Then it's good. Okay, okay. Okay, but the link is opening, right? Okay, that we can change. All right. So guys, we were looking into intercept form. Now, what is intercept? You know the meaning of the word intercept, right? Intercept means crossing over. Yeah. Yes, that is correct. So basically, we are talking about crossing over or connect plane cutting with the axes. Plane cutting with the axes. So that was intercept form. Both of you have got the NCRT with you also, right? Okay. Okay. Now, when we talk about the intercept form, so to find out the intercept, you can just divide with the constant. Divide with the constant means, I'll give you guys a quick question, rapid fire, without writing. All right. Murugasan, tell me the x-intercept of this plane, that is 2x plus 3y plus 4z equal to minus 10. What is x-intercept? X-intercept is x. X is a variable. Yes. That's an x-intercept? Minus 5. Express it in the intercept form. That means make this as 1. So what will happen? You write like this: 2x by minus 10 plus 3y by minus 10 plus 4z by minus 10. This is equal to 1. This is what will happen. Minus 5, yes. Minus 10 by 2 minus 10 by 3 minus 10 by 4. So this will be x, y, and z intercept. That's how we find it out. All right, so this is intercept form. Okay, I'll ask you one question as well. Okay, write it down. And what is the distance of this plane from origin? Yeah. Yeah, it will be 10 by root 29. So whether you get a minus or not, it doesn't matter because distance will be always positive. You are clear why it is 10 by root 29? Exactly. So, and again, always remember, every linear combination is going to be a plane. A line will have two equal to sign. Basically, they have linear combination equal to another linear combination. So that is what we have. So this is about equations of plane. Now we are done with equation of plane.
does we do that and we get distance?
Effectively, we are looking for foot of perpendicular. See, what effectively is happening, we know coefficients are the normal. Coefficients are the normal, right? Yeah, like coefficients are basically direction ratios of normal. Coefficient of x, y, z. Like if I ask you what is normal of this plane, what will be the answer? Normal of the plane. Murugasan? Yes.
It should be perpendicular.
Yes. Coefficients are the normal.
Oh,
So
yeah,
someone
yeah,
asks you, yeah, it will be 2i cap, 3j cap plus 4k cap. This will be the normal vector of the plane.
this is actually equation of plane.
It's the equation of plane.
Okay, sir. In that equation of plane, if x coordinate is normal, how can you say?
X coordinate is not normal. X coordinate, see, x, y, comma, z represents a point on this.
Yes, sir.
All right. Effectively, what I'm saying is, think about it like this. I'm saying normal is 2i cap, 3j cap, 4k cap. I am taking any random point. Like I've got the normal. This normal is 2i cap, 3j cap, 4k cap. I'm taking any random point. This random point have
Oh, that is x, y, z. So dot product is this.
correct. All right. So you can effectively you are saying that it comes because it is the giving you that point. Dot product is zero, but dot product is having some value because this point is a position vector, right? So first position vector of this point, then dot with this. See, ideally, if I take xi, yj, zk is this.
Yes, sir.
See, if this red pen is if this is the normal, the black one is the normal. It is 2i cap, 3j cap, 4k cap. Then their dot should be how much? 0. Now dot is not 0. Dot is coming out to minus 10 because this is not on the plane. This is a point on the plane. And we are talking about the position vector,
Okay, sir.
right? That is why.
That is why we are getting minus 10.
And yeah, and basically when you are taking the dot, so this is the this. So dot gives you what?
This, in the normal
Projection.
projection, what is this?
That is the distance from origin. Because position vector starts from origin.
So that particular point with respect to that origin, we dot product with that of the normal, we'll get the distance between that position and distance between the plane and origin.
Yes, correct. Absolutely. All right. In fact, we'll be using the same funda there in the next thing. So next thing that we are going to see regarding plane. So again, see, just like lines is one exercise, plane is also one exercise. So everything in the plane combined is one exercise. All right. So we'll finish all the topic ones. So the next
Distance will be minus 10. I mean 10.
no, distance is see because when you take projection, you take on unit vector. Otherwise, the vector will give its mod. Okay, what is dot product? Mod A, mod B, cos theta. But we do not want mod A, right? Because that is coming from the vector. Right? B cos theta will be the projection. So that's why it has to be unit vector.
So that normal unit vector only we are multiplying that of
Correct.
the distance.
Yes, exactly. Murugasan, clear?
Yes, sir.
How much?
90%.
That's great. Okay, so the next thing we are going to see is distance between point and plane. We'll see what is the distance between a point and a plane. Now, it follows the standard formula. All right. If you want to, you can, then we'll see the derivation, otherwise, not needed. All right. So, let's say if you have a plane over here. Now, this is the equation of plane ax plus by plus cz plus d equal to 0. This is the equation of plane. This is the point. Point is x1, comma y1, comma z1. So, and let's say this is d. D is the distance between point and plane. So we follow a standard method, that is dump the coordinates of the point on the plane and divide with the mod of normal. So the formula comes out to be distance d is given as ax1 plus by1 plus cz1 plus d divided by root over a square plus b square plus c square. This is what we get. So effectively, you are substituting this point over here and then dividing by this. These are okay. Wait a second. Let's call it something else. Let's call it this.
So that is the distance, right?
Yeah, this is distance. This d is nothing. Okay, I'll call change this one also. This is also we'll call it this.
So then small d is what?
Small d is the equation.
Oh, okay.
All right. I'll also tell you the idea how it comes out to be. See, if we take two parallel planes, if I take two parallel planes, these are the two parallel planes. We will find out distance of first from origin, distance of second from origin, and I'll subtract the distance. That will give you distance between the plane. So that's what we are doing. What is the normal vector of this plane? AI cap, bj cap, ck cap. This is the point x1 comma y1 comma z1. So what will be equation of plane passing through this point and parallel to this plane? That will be a point. Like you are giving me a value. Ax1 will become a value. It's not a variable. It will be a times x minus x1 plus b times y minus y1 plus c times z minus z1 equal to 0. We did right. A point and normal is given. A point and normal is given. So like that. Clear? Then we find out individually both the distance from origin and subtract it. So you get this. All right. So this is the distance between a point and plane. Now angle between line and plane is not there. Angle between plane and plane is also not there, right?
No angle.
No angle is there. So life is without angle. Okay. Then I think that's it. If angles are not there, then this is the only thing that you have. You have equation of plane. Okay. All right.
Coplanarity of two lines.
Okay. So we'll do family of planes also. All right. This is because I'm not sure whether it's there or not. So we'll do it. Okay. What we did?
Plane intersection.
Intersection of two planes. When did we did intersection of two planes?
Oh, that is intersection. Okay.
Intercept and intercept are different.
Yes, sir.
What is intercept? Okay, tell me what is intercept versus intersect. Intersect.
Intercept means meeting point. Like intersecting means like crossing.
No, not like that. Okay, let's say if I say something is going on, so you can intersect it or you intercept it. What?
Intersect.
You know the English meaning of intercept and intersect or not? What is that?
The intersect means like this.
Like this
No,
means?
intercept is this. Intersecting means while going we are joining. That is intersecting.
Okay, now apart from the exercise 11.2 and 3, the other thing is you go back home, search on any dictionary or Google that intercept versus intersect. All right, what is the difference? That difference need to be very clear. So intersecting means when someone is like they are basically cutting. All right, intercept is basically part which is cut out. See, for example, let's say if I have a circle, so or sphere, if I cut this, so whatever part is cut out, that is the intercept. Intersect means this thing.
The process is intersecting.
No. Okay, I'll tell you. Kind of you can say like this. See, if this is a circle, I'm cutting with a line. So this is the intercept, this part. This is the intercept. Intercept made by the line. When line is intersecting the circle. All right. Okay. So this is what we have. Now next we look about family of planes. This is also known as family of planes. When I say all the plane, like equation of plane passing through intersection of two planes. That's what is there, right? Intersection equation of plane passing through intersection of two planes. Now we have talked about family. What is family?
Many, all many members in a, same molecules like more related. More similarities.
We talked about how do you define a family? How do you define a family? When something is common, right? Then it is family. We have talked about your family as well. How did you define your family? And if definition goes wrong, then what will happen? Huh? Beating will happen, right? That is, family is very important. So family will have something in common. Family will have something in common. Now, what is that common? That is what we have to study in planes. All right. So we will see how to find out family of plane. Now, to determine a plane, how many points you needed? Points.
Plane.
Ah.
2 points. Oh, sorry, 3. But
Three.
I don't need 2 points.
All right. We require 3 points. So we require 3 points for a plane. Now, what we are saying is that, okay, so from 2 points, what happens? 2 points goes a line. So family of plane means all the planes which have a line in common. All right. Give me a notebook. Now, how many pages are there in this notebook? Okay, whatever. So you can think all these pages are the same family of plane. Why? Because if I talk about this plane, all pages is a plane, right? Every page I can think as a plane, although it's a rotating plane, not fixed. Right now, fixed. So all these planes have what in common? Common line of intersection. That's how we define family of planes. All right, and that is what we'll see.
All the planes having a common line.
Common line, yes. That is family of plane. So like a notebook, like your book. So they have a common intersecting line. Common intersecting line. So we say how we give equation of family of planes. So equation of family of plane passing through two. Passing through two means if two of the family member are P1 and P2, then it's given as P1 plus lambda P2 equal to 0. All right. So let us say we have like this. So let's say this is one plane, this is another plane, P1, P2. So what we are trying to do over here is we are saying that if we know two family members, then we can define the family. See, with one, it's very difficult to define, right? If only you are there, I do not know how to define the family. All right. I think that, okay, Prachun is with you, so I'll define family as classmates. All right. I'll think that you are with me. I'll define family as those who are staying in this academy right now. All right. So with like, so what will happen with single one? It's difficult to define. So we require two to define the family over here. So we are saying if P1, P2 are two family members or two planes, then equation of any plane passing through their intersecting line will be like this. P1 plus lambda P2 equal to 0. Now what is lambda? Lambda is some arbitrary constant. As the value of lambda will change, you get different family member. Like lambda equal to 1, one family member. Lambda equal to 2, another family member. Lambda equal to 3, another. So how many family members you can have? Infinite, because from a line you can have infinite numbers of plane passing through. So we'll understand an example. So if let's say you have this thing, x plus y plus z minus 2 equal to 0. This is one plane. And let's take another plane. Another plane is 2x plus 3y minus z equal to 8. So if someone asks you find out equation of a plane passing through the intersection of these two planes or the line of intersection of these two planes, so you will directly write it like this. It will be x plus y plus z minus 2 plus lambda times 2x plus 3y minus z minus 8 equal to 0. And different value of lambda will give you different values. Yes. Now, how you'll find out lambda? Based on the condition. So now, same thing I'll give you as a question. Tell me. Okay, so I'll give you same thing as a question. Now it's given that you have to find out equation of a plane. You have to find out equation of a plane passing through intersection of these two. Passing through intersection of these two such that it is perpendicular to the first plane. Such that it is perpendicular to the first plane. So find it out. You have to find out equation of a plane passing through intersection of these two planes such that it's perpendicular to the first plane. Okay, if two planes are, okay, all the angle between plane is not there, but to understand this, we'll understand a little bit. If two planes are perpendicular, what should be condition? Cross product of what?
Sorry, dot product
Of what?
two plane.
How do you find a dot product of plane? Does plane have a direction?
Normal.
Normal. Every time you think of direction of plane, you have to think direction of normal. So dot product of their normal should be 0. Now any plane which pass through their intersection will be like this. So other way around, we can write like this. We can write it as x 1 plus 2 lambda plus y times 1 plus 3 lambda plus z times 1 minus lambda minus 2 minus 8 lambda equal to 0. This is what we will get. Right? Now tell me what is the normal of this plane? K cap. Now it's dot with that. Should be 0. What is this? Normal? 1, 1, what? Yeah. Doesn't really matter. If anything is 0, product will also be 0. For 0, it doesn't matter. See, 0 into 8 is 0. 0 into 10 is 0. So for 0, it doesn't matter. If you want, you can do that, but it doesn't matter. So their dot should be 0. So where dot will come out to be this. I'll get 1 plus 2 lambda, taking I with I. Then taking j with j will get 1 plus 3 lambda and plus 1 minus lambda. This should be equal to 0. So what will be lambda? Lambda is minus 3 by 4. So once you put lambda is minus 3 by 4 here, you will get a plane which passes through intersection of these two and perpendicular to it.
So if they are perpendicular, we should do normal dot product and we should find the lambda value.
That's it. Alright. More than this won't come. And that's it. We are done.
Coplanarity of two lines. Coplanarity of two lines.
Okay, coplanarity of two lines, it is not removed.
It is removed.
Okay.
Coplanarity.
Alright, so we look for coplanarity of two lines. The question is you have to find out equation of plane passing through intersection of these two planes such that is perpendicular to the first plane.
Sir, and the plane passing through intersection of two given planes.
Plane passing, this is the thing, right? Family of planes. Alright, so you are saying coplanarity of two lines. Two lines.
Coplanarity of two lines.
Okay, now, okay, first you write down, then I'll tell you. We have also done that. Think about it how. Okay, when will be two lines will be coplanar in 3D? In 3D, when can two lines be coplanar? Are they coplanar? We found out distance between two lines, right? 0. That's it. Over.
So distance should be 0.
See, these lines are known as skew lines. Skew, S-K-E-W. Skew lines are non-intersecting, non-parallel lines, which are non-coplanar. They are skew lines. If distance between two lines is 0, they will be coplanar, or when they are parallel. So either the line should be parallel to be coplanar, or distance between the two lines should be 0. So distance between the two lines was, what is the formula? A2 minus A1 dot with B1 cross B2 by mod of B1 cross B2, where B1, B2 are the direction of the line, A1, A2 are points in the line. All right. The shortest distance. If that is 0, that means they are intersecting. Intersecting lines are coplanar. No, no, no. Distance between skew lines, not parallel lines. All right. So this is what we do. That's it. 3D over. But you have to practice, otherwise you'll forget all of this. I'm telling you what will happen. By tomorrow you'll practice vector 3D. All right. So if you go to integral, you'll forget something of it. All right. It will happen because you're doing in a very short time. All right. So what we need to do is do papers. You are there in common 12th group, right? Today a lot of people you must have come. So you have to finish all of that tomorrow. Tomorrow do the same thing, right? Day and night do paper. See, with the paper, good thing what will happen is you'll do each and every different type of question. You will not forget. Otherwise, you'll start forgetting integral now onwards. All right. So keep on doing that in between. Done? Okay. Now done? All right. So now we'll move on to the last chapter. That is probability. Okay. So tell me what is probability? Chance of what? Okay, actually probability is a big thing. All right. It's okay. That is in terms of J. I'll just be very, very limited. Will do to for your term. We'll only do that part from where question comes. I will assume that little bit of PNC, little bit of PNC. All right, that you know, right? Okay. So Murgasan, what is probability? Chance of something to happen. That is probability, right? Now, what are the chances that, let's say, when you when you go back home, so you'll fall on the stairs, right? Okay. Let's say I'm tossing a coin. What is the probability of getting a head? Right? I was very careful when I was tossing a coin. I wanted to get a head. Okay. Correct, right? So how do you do favorable case by total cases? That is probability, right? Now you're walking down the stairs. Two cases only there. You'll slip and fall down. You won't slip and you won't fall down. So one by two. Should be 1 by 2, right? So what is the probability of you falling down? 1 by 2. How many steps are there? How many steps are there? Okay. Give me a rough number. 50 steps. That is too much, but okay, we'll assume that 50 steps are there. Now, every time you have half of the chances, every single time, and you didn't fall in all the 50. Now, what is the probability of that happening? Why zero? No. I'll repeat my question. If probability of falling down in one step is half, what is the probability of you falling down in 50 steps? Okay, or probability of not falling down at all? 1 by 2 into 1 by 2 power 50. Now, 1 by 2 power 50 will be a very big number, very small number. Almost zero. That means you should fall. That means you should fall, right? It's not other way around. I'm not asking that probability of you falling at every step. You falling at every step is also 1 by 2 power 50. You not falling is also 1 by 2 power 50. But Murugasan, you are not falling. So why is this magic happening? I thought we are studying probability. But now you're telling me we are studying magic. So what is probability? Is it magic? Then? So now this is pure bullshit. It is not favorable case by total outcomes, total cases. All right, that happens in an unbiased case. Unbiased. That is very important part. All right, and you must have learned this in your very lower grade, or I don't know whether learned or not, but this is very basic. You should know that. Otherwise, randomly you say probability is this, na, your life will be upside down. It's a biased case. Bias. Okay, for one side favorable. Like, have you seen any movie in which like some main character will toss a coin, always head will come? Which movie? Always head will come, right? So why always head is coming? Because the bias. It's a bias case, right? Our main character have a special power, whatever that power is, or the coin have special power. He's just making fool by saying I have a special power. All right. So everything in life is probability. He do not want to fall down. That is his bias. He's cautious about it. Consciously, he's working on it. So that is the bias. All right. If you train yourself, even you will see that you can get heads more number of times. Why? Because you are biased when you are tossing the coin. So that's a bias. Bias probability is totally different game, ball game. All right, that you need not to do. All right, believe me, but probability is something very very fascinating. I don't know how much you are into tech, but a lot of medical research is also happening in terms of tech, stochastic processes, and blockchain, especially the this research part. I hope, in fact, you know about medical imaging, right? Imaging. Imaging in the sense, basically now in medical field, a lot of research is happening. Let's say you want to do whatever that, what I do not know what kind of scan it is, CT scan or X-ray, whatever it is. But just with that, how you can detect things at early stage, lower stage, whatever. Because right now, what happens? If I talk about normal medical science, there are a lot of factors, right? Lot of factors means just by taking X-ray, can you exactly determine 100% of time like what is happening? You'll say, okay, one or two tests, three tests, or maybe you require a experienced doctor because sometimes plenty of things are happening, right? What if you make it all automated? And why can't you make it all automated? All right, so that is also possible. In fact, one of my friend is doing that. Treatment cannot be automated. See, every time there will be an exception. My point is, it's not possible that there won't be any exception. It makes your life better at doing it. See, no technology can eliminate this part. But okay, for example, let's say 50 years back, 50 years back, how do you think that operation used to happen in operation theater?
Not very great equipment, just mostly with hands.
Now, how it is happening now?
Machines.
Now, have it defined or have it changed something significantly? What it has changed? What? So my point is, when I'm saying that all this you can do, right? It is a way to enhance survival rate, like because diagnosis is also a very important part, right? So my point is, this is not just about like it's not like machine can treat. You're getting my point, right? If some person thought this 50 years back, that machine can treat, then the current medical science is not like that, right? So my point is, do not like that is a fantasy. So what you're thinking is like fantasy, right? My point is, all these things help you to improve on a lot of things. All right, so that is if you're good at actually a branch of probability is known as stochastic processes. That is mixed of probability and statistics, and that is all. What is this thing that you must have heard? Yes, yes. You know, have you know about the stochastic process? Uh, so basically, stochastic processes is a proper stream of mathematics which deals with probability and statistics, and that is what is like. How should I say? Like everywhere, everything that works in the world, right? There'll be involvement of stochastic process. That is, statistics and probability like are really good. If you be good at it, you can do a lot of things. Like my point is, rather than being limited at one stream, see, that is you blocking yourself, right? So you can be much more than that. That's a very wonderful part of technology. So you can use it everywhere. So like one of my friend is doing that. So he's working on the same thing. So my point is similarly, right? Recently, have you heard about blockchain? Blockchain. Blockchain is also very good technology. So now things are shifting to blockchain. So now even that has started coming in medical sciences. All right. So you have heard about cryptocurrency, right? Bitcoin. That is based on blockchain technology. Like blockchain is a technology. But the integration is a like this thing, right? So for example, wireless communication is a technology. 5G is a technology, right? So it's not a object, it's not a product. So blockchain is a technology. So cryptocurrencies are basically based on that. And not just cryptocurrency, now a lot of things are also getting based on that. Apps or other things. Okay, so all of that have a lot of to do with probability and statistics. But we are not going to learn too much probability. We'll only learn Bayes theorem, total probability theorem, and very, very basic level. But yeah, I can suggest you maybe after your NEET exam get over, you can work on this. It'll be very fun. The more you know, the better you'll be. All right. And probability is too fun. We cannot do all that fun because time is less. Okay, so this is what we have. All right. So now we know it is probability is not that what you have told me, but considering your term exam and we don't have time to see how to find out. So for right now, you just think that probability is number of favorable outcome by total outcomes. Because in your term, they are not going to ask beyond that. All right. So number of favorable outcome by total outcome is the probability. In an unbiased case, that is the full statement. Unbiased case means when you assume coin is unbiased, or something is unbiased. Now probability have like one is basic probability. Basic probability you are supposed to do in 11. But if you are very weak in that, then we'll take it up because otherwise the application of basic probability also you'll do wrong. So are you very weak in that or what is the scene? Okay, I'll ask you a very simple question. Okay, I'll ask you only simple questions only. Now you tell me that we are drawing two cards. Two cards from a deck of 52 cards. So what is the probability of getting two king? Yeah. See, what? Okay, both. One after another and simultaneously. What will be the difference?
So 1 after the other means 1 by 52 plus 1 by 52. 4 by 52 into, oh sorry, 4 by 52 into 4 by 48 plus 4 by 48.
How many cards are left? Why you are counting the numbers? You have taken out only one, right? 51 are left.
Oh yes, sir. 4 by 52 into
3 by 51. When you do one after another. When you do simultaneously, And it won't change. It will be same. How it will change? Think about it. It cannot change. It just cannot change. It will be same. You are clear? Why? Okay. Now, can I say that? Okay, I'll do this mathematically. Logical part will skip. So, two king. How many kings are there? Four. I have to choose two out of four. In how many ways you can do that? Number of combinations, number of ways to pick two things out of four. 4c2. 4c2 divided by 52c2. Do this, you'll get the same thing. You get 4 into 3 divided by 52 into 51. Alright, it doesn't really matter. Alright, it doesn't really matter how you do it. Okay, what is 4CR? Okay, what is NCR? Yeah, NCR formula, yes. Okay, correct. I am happy. It is this. No, n minus r factorial. Okay. PNC is fun. How can you miss this out? Okay, fine. What are the reasons? My point is PNC is so fun you just cannot skip it out. If you learn properly, that given that. Okay. Yeah. You were not there in 10? Alright, fine. So this is NCR. NCR is this. So that's how you can find it out. So this is how you find out probability. Alright, I'll tell you basic definition. We won't do anything more than that. Then you apply Bayes theorem, total probability theorem. I think probability distribution is not in the syllabus anymore. Not there, right? And very simple. We'll finish in half an hour. Okay, so this is how you find out basic probability. Now, after we are done with basic probability, we just need to study two or three things. First thing we will talk about is, okay, you know what is event in probability? What is event?
Event means that take into part. I mean, they take into part that phenomenon.
No, that is not event. It's not like real life event. In probability, event means a subset of sample space. What is sample space? All possible outcomes. All right. So, for example, if I say that Murugasan is walking down the stairs, so what is the sample space? So, there are two things in sample space. All right, that is a sample space. Event will be some outcomes out of the sample space. All right. So, when you roll a dice, sample space will be all the numbers 1 to 6. 1, 2, 3, 4, 5, 6. But if I say getting an even number means event will be 2, 4, 6. So event is a subset of sample space. That means it's a set of some outcomes out of all outcomes. That's an event. So we say that two events are mutually exclusive. Two events are mutually exclusive. Two events are mutually exclusive if they do not have any common element. Or I can say that if one event is A, other is B, then probability of A intersection B should be 0. Or I can say the set A intersection B should be the null set phi. That is mutually exclusive events. Next thing that we will study is conditional probability. Next thing that we'll study is conditional probability. Next is conditional probability. Now, conditional probability means some condition will be given, and based on that, you have to find it out. For example, let's say I'm rolling a dice. All right. Now, if I, and let's say, like, Murugasan is doing some betting. All right. Betting, right? So, Murugasan is doing some betting. Now, he's betting that outcome will be 5. And he's placing some, let's say, 100 rupees on it. Now, if I say that Murugasan outcome is an odd number, then will you let your bet remain over there or will you change your bet? I'll change. If I say outcome is an even number, then will you be happy or sad? Happy because chances increase. So conditional probability is probability of something to happen, given that another event has happened. Another event has happened. It's represented like this: probability of A given B. That means probability of A to happen given B have already occurred, and it's given as probability of A intersection B by PB. You know this much? All right. Why it is like this? You don't know. Okay.
Intersection means common point, sir.
Correct.
So common thing is it both should match with
Yes. See, because ultimately I was saying there was something in A, something in B. Now I'm saying Murugasan B have happened. That means only B is possible, right? And out of B you want to find out A. So that will be the common elements. Common elements. And now because just your total probability is not 1, it has become same as B. So this is like favorable by total. Again, same thing. This is conditional probability. All right. Okay. All right. I'll give you a question. Let's say we are rolling a dice. We are rolling a dice. You have to, and we are defining an event A getting a multiple of 3. We are defining an event B getting an odd number. You have to find out probability of A given B. You have to find out probability of getting a multiple of 3 given that the outcome is 1, 3 or 6. Okay. 5. Okay, I said odd number. 5. So what will be the answer? Why 1 by 3, Murugasan? Why 1 by 3?
so because A intersection B is only 3, sir. So B
Only one element, 3. Right? And total are 3. So 1 by 3. Simple. Easy and simple. Clear? Next, we'll look into what are independent events. So we say that two events are independent if occurrence of one is not affecting occurrence of other. All right. That means if someone comes and tell you that this is the outcome, it won't affect your bet, right? Because you say, "Are still probability is not changing; it is still the same." Occurrence of one event is not affecting the occurrence of other. So mathematically, we write it like this: that is probability of A given. No, it is basically conditional probability. I'm saying that even if I take conditional probability, it didn't change. Conditional probability of A under B, if it is still same as probability of A, that means A and B are independent. So occurrence of B is not affecting the occurrence of A. Okay. Now I'll ask you a question. Okay, we also write it like this. I'll write it the other form of it. We also write it as that P of A intersection B is PA into PB. Now basically I'm converting this to this form. The second one is the standard formula. Probability of we should be probability of A into B, only then they will be independent. Only then they will be independent. All right, so that is what we talk about conditional probability. All right, so this is conditional probability. Now, if we are saying that in conditional probability, if this happens, then we call them events to be independent. We call the event to be independent. All right, fine. Okay, I think we can take some question from 13.1 before going ahead. Okay.
Multiplication theorem.
That is your nothing. We'll see. That is almost nothing. This is multiplication theorem. Not this. Okay, I'll tell you what is that. So this is this is independent events.
So it will be 0.
What?
So answer will be 0.
Zero for what?
I mean, independent event means it doesn't affect. So probably it will be 0.
Why?
So
Okay.
then what will be? Then 3 will be.
Okay. I'm rolling a dice. One event is getting a odd number. Other is getting a even number. Are they independent? No. They are an example of perfectly dependent events. If odd happen, even cannot happen. If even happen, odd cannot happen. That means they're dependent on each other. Got it or not? Got it? So mutually exclusive events are always dependent. They're a perfect example of dependency. All right. If I say that Murugasan, tomorrow you have to run. All right. And if I say today you fell down off the stairs, are they independent or dependent? Dependent, right? Same thing over here. If one happen, other cannot happen.
Any independent event.
This. This. What is probability of A? The probability since when it becomes two, more than one. Probability of A, only A, forget B. What is probability of A? That is, what is probability of A given B? Independent. Now I'll tell you this. With a single, there are two things. In a single experiment or in multiple experiment. In a single experiment, when two events are independent, that is difficult to analyze. Do not even try to do that. It will take at least some good 3-4 hours of teaching you guys to understand that. All right, for that, go with the formula right now. For two distinct events or two distinct experiments, that I can tell you. You roll a dice, you toss a coin. So getting a head in the coin is independent of getting a 2 in the dice, right? So they are independent. So what is the probability of getting 2 in the dice? 1 by 6. What is the probability of getting a head in the this? 1 by 2. So even if I say 1 has occurred, the other probability will not change.
Then we should multiply the code.
Yes. So okay, if I ask you what is the probability of getting a 2 and a head, so what will be that? 1 by 12. That is same as their product. Because this is 1 by 6 into this. Whenever two things happen in succession, one after another, you multiply. Either or means you add. This much you know,
That
right?
is for independent event only we should do this.
No. Succession means it will always multiply. It's just that everything which happens in succession will be obviously independent. If there are two different experiments. Same experiment, two events. That is not that easy.
So succession means
But they won't ask you. This is like a starting level of advanced level question. Skip it.
succession means like
Okay. Got it?
so for understanding is 1, 3, 5. That's same event only. Like getting even, getting one.
No. They are different types of events. And if one happen, other cannot happen. It will affect your decision. Right? If I told Murugasan that he's betting on 4, but outcome is odd, it's affecting his decision, right? It's not independent. It's dependent. These two are independent. So two independent events will definitely have something in common. Definitely. Otherwise, not possible. Alright, so these independent events. Now, till now we have covered two exercises. So I'll say that rather than taking more, first of all, you do Murugasan, which question number you will do? 13.1.
Me, sir.
Huh.
I'll do first question.
First question. Do first question, both of you. From 13.1. Do the first question. After doing the first question, see which question you feel is kind of lengthy and so on. Let me know. We'll do that one on board. Or first shall I do, then you will do.
The third thing,
13th one. Okay, I'll do 13th one first, then you do the first one.
this is basic problem.
This is basic probability. There's like nothing in this. Like with a basic probability, they'll ask you like how to find out conditional probability, this and that, which is very simple. 13th one you're asking, right? In 13th one is given that you have 300 easy, like this exercise. true and false questions, and 200 difficult, unlike NCRT, true and false questions, and 500 easy MCQ, and 400. Okay, I'll write it. We have 300 easy T and F. We have 200 difficult T and F. We have 500 easy MCQ. Then we have, then after that we have 400 difficult MCQ. Now, if a question is selected at random from the question bank, what is the probability that it's an easy question? Given that it's a, okay, so we have to find out probability of an easy question, given that it's a MCQ. Now, what kind of probability you can see over here? Conditional probability. And in conditional probability, how we simplify it? It will be probability of E intersection MCQ divided by probability of MCQ. Now this you could have done without this by basic thinking. It will be 5NA. In fact, you could have done this without even this, right? So that's one thing. Probability is very obvious. Probability is very obvious. Even a difficult question of probability is obvious.
Big question will be easier, small question will be
Yes. So I did the easy one. Now Murugasan will do the tough one. First one. So this is very obvious, right? That's why conditional probability is very obvious. Half of the formula in probability are obvious.
probability of A union B, we can use it for all the events.
No. For you're asking for which one? A union B.
It's a intersection.
No, that is only for independent event. The product.
So if dependent events are there, we cannot use that.
No, you cannot use that.
Conditional probability is a dependent event.
No, conditional probabilities like have nothing to do. It's just a conditional probability. It doesn't matter whether they are dependent or independent. It has nothing to do with anything. If conditional probability is same as original probability, then it become independent. If not, they become dependent. See, conditional probability have nothing to do with dependency, independency. It has like it is something out there.
What happened with respect to that? What is it?
Yes, that's it. Over. First one done. Correct. Easy. And that's it. This entire exercise you will find it like that. Just think logically, it's like very nothing. Second exercise also think logically, it's nothing.
Multiplication.
Multiplication theorem, I'll tell you what is multiplication theorem. It's like pure. Okay, Murugasan, do you know how to cross multiply? A by B equal to C by D. Equal to C by D. Then what is AC? That's it. That is its multiplication theorem. Okay, now you see this? You see this? Can I cross multiply? That is multiplication theorem. So cross multiply, that's it. So P of B into P of A given B. This is P of A intersection B. This is what it is. Now tell me how difficult is that? Look at the multiplication theorem. Do you see something similar? That's it. I will do a bit total probability theorem, base theorem. They will see that. See, in fact, total probability theorem, base theorem is also very obvious. It's just that if you want to articulate it, then for articulation, we have to use it like that. Okay, so we'll do that example. So I'll do one thing. 8 point, like that second exercise you do on your own. It's very simple, nothing difficult. If you're having difficulty, you will see later. I'll just directly jump to total probability theorem and base theorem. It's very obvious. We'll see both through formula and without formula. We'll see that why it was so obvious. Like why do you need formula? Stupidity. So we'll see both the ways. Now, what do you understand by total probability theorem? From total, we have to find out, right? So we have said that a sample space is a set, an event is a subset. For every set, I can use Venn diagram. I'll draw the Venn diagram. Let's say this is my sample space. All right. And in the sample space, I have a lot of events that are A1, A2, A3, and so on up to AN. So we are saying we have n mutually exclusive exhaustive events. Mutually exclusive exhaustive events. So n mutually exclusive exhaustive events we have, they are A1, A2, so on up to AN. Mutually exclusive means nothing in common. Intersection is zero. Intersection is zero for all of them. Exhaustive means complete. Together they are complete. When do you get exhausted? In math, in bio, energy is still there. Chemistry, chemistry is fun. Physics, okay. So exhaustive means completely everything is gone, right? So exhaustive means complete set. That is exhaustive. So if they are exhaustive means together they are everything. All right. So they are n mutually exclusive exhaustive events. Then what? Complete. Like exhaustive means together it is sample space. Union is sample space. Or like they're complete. There is nothing outside it. So if you have n mutually exclusive exhaustive events and we have some random event B spanning over few of them or some of them. This is our event B which spans over few of them or some of them. Then according to total probability theorem, we say that total probability of B will be this piecewise probability, like add this, then add this, then add this, and so on, like add this. What do you understand by total? Total is sum of all. That's exactly what you're doing. Total probability of B will be sum of all these small probabilities. Now this we will write it as summation of I goes from 1 to n, then what AI? Okay, we'll say it's P of AI into P of B given AI. Now you understood this formula, Murugasan? Then explain.
Sir, but P of A means how much it is occupied, and P of A means how much it is interception by that interception by. So total is given by interception area. I mean, total interception they have given. So like, because P of
You're asking, you're telling.
I'm telling you.
Okay.
One intersection of B and A is there.
Okay. Are you guys clear by looking at this formula? What is total probability theorem?
Mutually exclusive.
Nothing in common.
Nothing in common and all are
Together are everything.
okay, together as a unit and each one is independent.
Not independent. If two events are independent, they will be never mutually exclusive.
Okay, they are dependent but
And mutually exclusive, both.
dependent exclusive.
Dependent is not of any dependent, independent is not at all needed.
Like solar system.
Mutually exclusive. Mutually exclusive.
Like solar system.
Solar
Sun
system?
and Earth that are not.
They are in one solar system.
Yes, yes.
Two solar systems are mutually exclusive because they can have nothing in common.
Okay, nothing in common but exclusive means, but both are independent.
See, exclusive is apart, not including. Inclusion, exclusion, right?
Okay, okay. One solar system.
So mutually exclusive means they are mutually they have nothing in common.
Means,
Okay. Now what is this formula? This formula is nothing but very simple. Well, that is fine, but it is something very obvious. Like it doesn't look very obvious right now. Now we'll see why it is obvious. Can I say total probability of B will be if I add this small probability? I'll add this one first, then this one, then this one, then this one. Now what will be this region? It is the common region of B and A1. How do I write common region? Intersection. So I'll write it as P of A1 intersection B. Then I have to add what? A2 intersection B. Then I add what? Like this, till what I'll add? A and intersection B. Now, according to a very, very difficult concept, that is cross multiplication. All right. According to this very super difficult concept, what have we learned? Probability of A intersection B is P of B into P of A given B. That is this. Simple. That is total probability theorem. All right. Now we'll take a question. You will see that even that is not needed. It is so obvious. We'll take a question. Do not think total probability theorem. Do it normally. Okay. Then we'll see what you are thinking is total probability theorem. Okay. Now Murugasan, let's assume that you went somewhere. All right. You found 3 bags. All right. Now it's been told to you that in one bag there is 2 gold balls, like full big ball made of gold. Will you be happy or sad? And it's given that there are 3 iron balls. All right. And there's another bag, bag 2. Bag 2 have 3 gold balls, but 5 iron balls. And bag 4, sorry, bag 3, sorry. Bag 3 have 1 gold ball and 2 iron balls. Okay. Now, what happened, Murugasan? Okay. Parents are asking. Have you informed? All right. Let's say Murugasan went on a hike. You found 3 bags. All right. One bag have 2 gold balls, 3 iron balls. Second have 3 gold, 5 iron. Last have 1 gold, 2 iron balls. And let's say I'll give you only one chance that you pick one ball from any of the bag. Now, what do you want? And what if you get iron? Will you smash your head with that? Why you didn't get gold? Huh? All right. So now I'll ask you, Murugasan, tell me what is the probability of getting a gold ball? Yeah. I'm giving you a combined option, na? See what is happening to you? You came, 3 bags are there. You have to pick one ball from any of the bag. Now you tell me what is probability of getting gold ball? What? 1/3 for? Correct. Middle one? First one? But tell me total, like what is the your probability of getting gold ball? See, you what all you will do first. Like there are 2 processes, right? First process is choose a bag. Second process is yeah. So what will be that? Why plus? If you add, probability will become more than 1. I'll give you 10 bags. Probability will be more than 1. You'll be happy. Okay, definitely one gold ball. I'll be going back with. Okay. So first I have to pick a bag. So picking this bag probability will be how much? 1 by 3. Then what is the probability of gold from this bag? 2 by 5. This will multiply, right? Just have to one after another section will multiply. So either you will do this, either this or second bag. So or this is what we'll do, right? This is the total probability getting gold. That is total probability theorem. Now, did you use this formula or did you do obvious like by obvious reasoning? Obvious reasoning, right? Now we'll see what is this formula. This is also very obvious.
So like in exam, you should do by this formula, however you want to do.
Write this formula, then do however you want to do. Step marks you'll get full. Answer is also correct. Nothing to worry. All right. Now P of A signifies probability of picking a bag. You picked a bag that was 1 by 3, 1 by 3, 1 by 3. Then you picked gold given bag. Gold given bag B1. That is gold given bag B1. That is total probability theorem. All right. So do not go with the formula. Go with the logic. Everything will be very fast. Done. Total probability theorem. Answer you also got. So what is the probability of getting a gold? What? It will be always less than one. Even more than one, like suddenly gold will come from everywhere. All right. So this is total probability theorem. Now next is Bayes theorem. Have you heard Bayes theorem? Bayes theorem is there in syllabus, right? Okay. Fine. So Bayes theorem is the last topic. After that, over term syllabus. All right. Now what is Bayes theorem? Bayes theorem is nothing but same thing, total probability theorem. I'll twist this question. That Murugasan, you went lucky. You got a gold ball. Now tell me what is the probability that you picked it from back to ulta. Exactly, that is Bayes theorem. That's it.
So 1 by 3 is the
Okay, I'll tell you. Let's say a ball is picked at random. It found out to be of gold. Ball is picked at random. It found out to be of gold. What is the probability it belongs to back to? Now, how do you find probability? In the beginning, you told me something, right? So, what is the favorable outcome? That's it. That's Bayes theorem. Over. Done. Term, term syllabus over. That's it. Okay, I'll just write what is Bayes theorem. Now we are saying this is total probability, so I have to divide with this and favorable case, right? So it's ulta. Now we are finding out probability of B. I'll find out probability of AJ given B. Probability of bag given gold. So what will be that? According to conditional probability should be this intersection B by summation of I goes from 1 to n P of AI into P of B given AI. Like J is fixed, but I is changing. All right. Now, according to a very difficult concept that we have learned, what is probability of AJ intersection B? Right? So we'll write this. That is probability of this we can write it as probability of AJ into probability of B given AJ. This total probability theorem. Sorry, Bayes theorem. It's just ulta other way around. All right. So if you cannot relate to formula, leave the formula. Write formula. Do it obviously. Obvious logic. Other use it. Up to you. If you just think, you will see that array. It's very easy, right? That's it, guys. So we are done with the term 2 syllabus. Over. All right. What we will do is medical question. Okay, tell me. Tell me the medical question. Bernal trial. Bernal trial is even more simple. Okay, I'll tell you quickly. Bernal trial. I'm not sure. I'm not sure. What? Okay, Bernal trial means if outcome there are only two outcomes. Anything which have two outcomes is called Bernal trial. Success and failure. Now tell me an example of anything which have two outcome. You falling down on the stairs or not falling down on the stairs. Success is not falling down. Failure is falling down. So we call it success or failure. That's it. Now if I ask you that I want our success, I want our success in n trials. So what you'll do first, you will have to choose which all are you will have success. So in how many ways you can choose R out of N? NCR. I want R success out of N. Now let's say probability of success is X. Yeah. Let's say P is probability of success. P is probability of success. So how many times I'm getting success? R times. The answer, NCR is picking which trials I'll get success. Then how many times I'm getting success? R times. So how many times I'll multiply P? R times. See, if I say you are getting head 3 times, what is the probability? Half into half into half. So multiply it, right? So I'm getting R times success. So we'll put P per R. P into P into P, right? R times, right? And by default, remaining will be failure. What is the probability of failure? 1 minus P whole power n minus R. That's it. For knowledge trial. We are choosing in which trials you will have success out of the n trials. Okay, I'll give you an example. Let's say I'm tossing a coin 3 times. I want one head. One head. So obviously remaining two will be tail. So what is the probability of getting one head? One by eight. But that there won't be one case, right? You can get head, tail, 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 head, tail. So 3 times you'll get one by eight. So 3 by 8. Will be 3 by 8, right? Probably getting one head.
So 1 by 8, 1 by 8, 1 by 8, sir. Sorry, 1 by 8, sir. Then 3 by 8. Because HTT, that.
Okay, yeah. That is I3. H. You can get HTT, TTH, THT. 3 different ways you can get 1 by 8, right? That's it. NCR different ways. This. Over.
Yes, sir. NCR will go.
Okay. Done. Over. Syllabus. All right. Now, Murugasan, what you should do? Which one? Okay, tell me which question it is. Which one? 552. Okay, it's given that suppose a reliability of a HIV test is specified as follow. That means a person which have HIV, 90% of the test detects the disease, but 10% go undetected. So probability of detection given HIV is 9 by 10. So obviously probability of not detecting given HIV is 1 by 10. Alright. Of people having HIV, 90% is this. Of people free of HIV. People free of HIV, 99% of the tests are just HIV negative. So probability of not detecting given no HIV is 99 by 100. So obviously the other one will be 1%. That is not even needed to write. Detected non-HIV is 1 by 100. Okay. Now a large population of which only 0.1% have HIV. A large population of which only 0.1% have HIV. 1% is selected at random and given the HIV test, and the pathologist report him or her as positive. So out of how many are there? 1% is selected at random. 1% is selected at random, and we said it came out to be positive. It came out to be positive. So we have to find out that it have HIV. It have HIV given positive. This is what we have to find out. It's want to find out HIV given positive. Now, Murugasan, tell me your favorable outcome. Yeah. That means it should come out to be positive and should have HIV. It should be both positive and HIV. That is my favorable outcome, right? So HIV and positive. So how many it is? Yeah. No. HIV itself is this 1/1000. Like 0.1% of population have HIV, right? So what I want? I want HIV given positive. So my favorite case is both, that I'm getting both HIV and positive, like HIV intersection positive. So HIV, those who have HIV are 1/1000 into also came out to be positive. All right. So what is what into 9/10? Because they should also get detected, right? Like by positive, I mean D. Positive is detected. Okay, I'll change it. Detected. Now clear, right? So should be that. So it will be 9/10 divided by total probability. In how many ways you can get HIV? Total probability of getting HIV tested positive is that you had and get tested positive. So that is obviously the same thing. It's the same thing, right? You had and you get tested positive, or you didn't have, you still got tested positive. So didn't have will be into, so you didn't have, you still get positive. That's it. Base zero.
One person is selected and he is tested positive, sir. That only is question, sir.
The question is one person selected, he tested positive. So does he really have HIV or not?
Okay, sir. He is having, assuming that he is having HIV, sir.
No. I picked you. All right, you got tested positive. Now it's not necessary that you really had it, right?
Yes, sir.
You can have both. You really had it or not. Now the question is, one person selected at random. It's found out that he is HIV positive. So does he really have HIV? Probability of that.
Okay, sir. Now what you
So what I'm saying is, I want to find out what I want to find out that he got tested positive and he should also have HIV. So my favorable case is that he should be positive HIV and got tested positive. So positive HIV means 1/1000 and also tested positive 9/10. Because see, I detected the right person. I should not detect the wrong person, right? I detected the right person. Total probabilities, I detected the right person and I detected the wrong person. So right person, wrong person. This total detection. Total detection is total probability theorem. Total detection, and out of that, favorable is detected right person.
so the second denominator second term is wrong person picked up. That is 99 by wrong person that's not having HIV picked up and he still have a positive test.
Yes. That's it, right? Base theorem, simple, logical, no need for formula. Alright guys, so we'll stop over here. Alright, I'll continue this later. But practice, probability is pure practice. Otherwise, there's nothing theory, right? Was there anything? Simple cross multiplication you have learned, Murugasan, in name of probability.